What is the area of the region completely bounded by the curve negative x squared plus x plus 6 and the line y equals to 4? So before we start, you should be able to try to sketch the region described. So here is our graph, the graph of the quadratic. This is the graph of quadratic that opens down. This is the quadratic that opens down because a is negative, so it's going to look like this. All right, it is going to look like this. Now, it might not be exactly where the two lines meet, but one graph is going to look like that, and the next graph, which is the graph y equals to 4, 1, 2, 3, 4, will look like this. And so this is the region we're interested in. We want to find the area of this region, and by creating a simple sketch, we know which function is the top function. So this is the top function, this is the top function, and this is the bottom function, So what we have to do now is we have to find where the two lines intersect so that we know our boundary to integrate. Now what we can do is to determine where they intersect, with a graphing calculator we can graph both of them and find their intersection. But without a graphing calculator, say if this was a non-calculator problem, then we would have to set these two graphs equal to each other, so it would look like this. So this is my top graph, so I want to set my top graph equal to my bottom graph or function. So the top function is this, so intersection. Alright, to find the intersection, you set them equal to each other. The bottom function is 4, and then eventually you solve. You set it equal to 0. This is going to return a 2, and then we make sure that the top term or the first term is positive by multiplying everything by -1, and then we factor that equals to x. If you create an x box, what two numbers multiply to give you -2 but add to give you -1? And those two numbers are -2 and +1. So x minus 2 and x plus 1. So by solving for each binomial, set that equal to 0. When you solve for x, you get x equals to -1. When you solve for x, you get x equals to 2 for that guy. So the boundary will be -1 and 2. So my drawing was a little bit off here. It would have been a bit more to the left of the y-axis. But anyway, so the boundary is -1 to 2. And now we integrate. So we go, the area is going to be the integral from -1 to 2. Top function, this is the top function. Okay, minus the bottom function, so -4. So basically it comes out to be from -1 to 2, -x squared plus x plus 2 dx. We can either do this by hand or do it on a graphing calculator. This would be a typical by hand problem, but I'm going to show you the answer through a graphing calculator so that we can save time. Okay, so -1 to 2, x squared plus x plus 2 dx right here, and that's going to give us 10.5. Now 10.5 is, if you think about it, 10.5 is where? Which of the following items equals to 10.5? Well, it does not seem like any one of them equals to 10.5, but I could be wrong, so let's try it again. Plus 2 dx, and the area, no, 4.5. So earlier I think I had an x squared. 4.5, 9 over 2 is 4.5, so there it is. Alright, last problem for us over here. This is an AP question. Well, the last two problems that we did were also AP questions. Those are multiple choice sections. This is a free response question. A graphing calculator is required for some or part of this problem. So this is R, this is the region we're interested in. There are two graphs for region R as shown above, and they want us to find the area of R. So the first thing we need to do is we need to determine which curve belongs to sine of pi x, which curve belongs to x cubed minus 4x, because a calculator is allowed. We can easily graph both curves, perhaps starting with the sine of pi x, and let's set our window according to what they had here. So window from 0 to 2, there's 2, there is 2, and the y window from -3 to 1. So -3 all up to 1. Okay, and let's graph the first curve first. So as you can see, this first curve matches up with this first curve. So then we know that this top curve is sine of pi x. Okay, and that makes the bottom curve the curve x cubed minus 4x. Okay, so now we find the area. Before you even start using the calculator to find the area, you need to show your setup. So here is what I mean by that. So the first thing we do is we go the area of R is equal to the integral from 0, this is where the two curves meet, and 2, of the top function minus the bottom function. So again, whenever you see more than one term in the bottom function, you need to put them around a parentheses, a pair of parentheses, so that you can so that you remember to distribute that negative. So let's go ahead and integrate. So math option 9 from 0 to 2. The first curve is, oh, and by the way, I want to make sure that because I'm working with trig function, I want to make sure I'm in radian mode, which I am. So quit. There you go. And then we're going to type in sine of pi x minus parentheses, okay, parentheses, x cubed minus 4x dx. And there you go. And that should give us the area, which is 4. So the area is 4. Okay. All right. So it says the horizontal line y equals to -2. So the horizontal line y equals to -2, which would look something like this. Y equals to -2. Okay. Split the region R into two parts. So here is the first part and the second part. Write but do not evaluate an integral expression for the area of the part that's below the horizontal line. So in other words, they want us to set up an integral to find the area of this region, but do not integrate. So to find the area of that region, we need to determine which curve is the top curve and which curve is the bottom curve. So by looking at this region, you can kind of clearly see that this horizontal line is the top function, and then this function here is the bottom function. So far, here's what we know: the integral area. So the area is equal to, you have your top, this is your top, okay, minus, and then here's your bottom, x cubed minus 4x dx. Now, the only thing we need to figure out is where do these two graph intersect so that we can set up our bounds, our bound of integration. So this is where we take that curve, y equals to -2, and we punch it in here. So y equals to -2, and then we're going to punch it in the bottom curve, x cubed minus 4x. Graph both of them. They are going to intersect right there as we've seen in the drawing. We now determine where they intersect. So second, calculate the intersection of, so here's your first curve, that's your second curve, and it'll tell us that intersects right there, which is 0.539. So the bottom bound is 0.539. Now, what about the other intersection? So we do it again. Second, calculate the intersection. And then you move this particle over to as close to that other intersection as you possibly can. Hit enter again, and then you get an intersection of 1.675. So 1.675. This is the integral that represents the area of this region, which is the region in question. They said write but do not evaluate, which we did. We wrote one, so we don't have to evaluate. We are done.